When I did my first 3D print ever, about 15 years ago, it broke as soon as I took it off the 3D printer. And as soon as it broke, I took one look at it and realised I should have known that was going to break like that. And I sort of had to make that mistake to remind myself of something that I really ought to have known instinctively. Anyway, in this particular video, I'm going to be looking at the orientation of the build when you put it in the 3D printer and how that affects 3D printing strength. While this might seem quite obvious to many people, I have learned in my work to never assume that knowledge will be instinctively known, and therefore I think it's worth running this test, even though I feel like I can predict the outcomes. It's worth verifying my opinions with data, and who knows, I may actually be surprised. The plan is to take a test piece printed straight up and down and compare it to the same test piece printed horizontally, and I'll be printing that using my ready to run test rig, which has been mounted to this nice, slightly aged but still functioning piece of red gum that I found out in the backyard. I'm going to go and draw and 3D print the test piece to sit into the cradle here, then come back and test it to destruction, measuring how much force is required to destroy it using my Arduino-powered load testing system over here. For this part, I'm going to be building a very simple test beam. It's going to be square and the dimensions will be 10 millimeters. By 70 millimeters. And that's it. I'm not going to do any fillets or anything fancy on that square right now. I'll save that for later on in a future video and open it up in Cura. And I have two copies of that. One which is going to be printed on its side like this, and the other one which will be printed standing upright like so. I'll use a standard 50% fill for both of these prints. I have a print time of 1.5 hours estimated, which will probably be more like around about 1 hour. Of course, it's over to the 3D printer. All right, that's a little while later. I'm out here and I've got what appears to be essentially two identical prints, except this one was printed standing straight upright like this, and this one was printed horizontally like this. I'm going to set them both up in the arbor press here and measure how much force each one takes before it breaks. For interest's sake, I also have what makes up to the same thickness of paddle pop sticks, and I'm going to put these in and find out which is stronger. To begin with, I'm going to test the horizontally oriented 3D print. So I'll reset my meter here. I better zero that to tear it and reset that. This is a problem I have already. The angle of my handle isn't really where I'd like it to be, so I'm going to adjust that, and that's not too difficult to do. Just an Allen key onto that retaining collar there, whip out the except when it goes on the floor and right under the bench, all the way to the back. And the weight of the handle has around 24 newtons on it. Just going to load this up now. The fail point of the 3D print was 732 Newton, and here is the result of that. Now I'll test the beam which was printed vertically. And I do have a prediction here, but I'm going to keep it to myself. The other half of this I haven't been able to retrieve. I'm not surprised that the reading was lower than the first reading. What I am surprised at is how high this reading is. At close enough to 690 newtons, this took a lot more force than what I expected it to. You can see that in both of these pieces there is that whitening, which I do think is probably from tension. The next question, is this plastic any stronger than a similar thickness worth of paddle pop sticks? So here we go. And the paddle pop sticks failed there at 470 newtons, which makes both of these 3D print settings stronger than a set of paddle pop sticks. Alright, I've had a little bit of camera trouble in this video, so hopefully I've got enough footage of all of that to make it all work. A summary of that experiment: what I expected was that the vertically oriented 3D print would be much weaker than the horizontally oriented 3D print, and the numbers confirm that is true. What I wasn't expecting, however, is for those numbers to be quite close together. And in fact, the vertically oriented 3D print was much stronger than I expected it would have been, considering by the fact that it is sliced in that way, has built-in stress risers. I was very impressed with how much force was actually put into the test beam before it finally failed. That's my first 3D printer settings test to be done using this test rig, and there are more to come. So if you like this kind of video, keep watching. I'll see you later.